This video on First Updates Now is made possible by viewers like you and also the following sponsors. SOLIDWORKS is free for first teams. Over 80% of US engineering schools and 370,000 plus companies use SOLIDWORKS to design great products. SOLIDWORKS can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. And welcome back. We have team number 948. NRG is on right now, coming out of Bellevue, Washington. We're very excited to have NRG on. First time, first year in the Open Alliance, first time on the Open Alliance show. So love to hear more about the two of you as well. Tell us who you are and what you do on the team. And of course, we'll be talking about a lot about your build season progress so far.
Well, hi, I'm Taylor. I'm the Chief Technical Officer of NRG, and this is Tyga.
I'm Tyga. I'm the systems lead and documentation lead for NRG.
So charged up game coming in. How is NRG feeling so far? I know we'll be going through some of your build logs and how you've been tackling the process. What's your initial feeling going into this year's game? And then walk us into how you went through some of the strategy process as well.
Yeah, so it was definitely a surprise for us watching kickoff at our shop. It was a game we were not expecting, but definitely surprised by it. And we had a whole kickoff event for Saturday and Sunday at our shop. And yeah, we're excited to present some of the strategies and like priorities that we've come up with for our robot.
Yeah, walk us through how that went down and what some of your priorities are.
Okay. We're gonna share the robot priorities.
All right. Oh, sorry. Right over here.
All right. So for auto and for the game in general, we figured that scoring high was like the main priority, since it would be like with the max amount of points that you can get. We were going to go high and balance, because that's like the two things, the important two things that you can do. And then we prioritize top row, then middle row, and then hybrid. And for us, more of our prototypes are focused towards cones versus cubes, because we figured there are more cones on the field, and cones are just harder to design towards versus a cube, which is symmetrical. And so, yeah, our design process kind of like figuring out how our intake that picks up the cone can also pick up the cube. Yeah. And then we've also had some talks about the cooperation grid and like waiting to do that for last to see if we really need it or not. So yeah.
Greg, that's something we haven't heard from the other OA teams tonight, is the cooperation grid and how that's approached. So I'm interested to hear energy from your team. How like you said, you're going to wait. That's more towards the end of matches. Is that something that you still want to get done every match, or is that something that you're going to take on a case-by-case basis?
Yeah, so for us, it's really a case-by-case basis, because it's more of like, do we really need to like get it, or can we go without it? Because if we can go without it, then it's not worth going for the cooperation grid, and instead just getting those 5 links instead. So we'll let the drive coach pick.
Fair.
Yeah, I mean, that is one of the nice things about this game, though, is that if you focus actually on the scoring part of it, and you can effectively score on anywhere there, the strategy of which robot can score where and when, what the order is kind of a on match demand thing. So I think I agree that you don't need to know that right this second.
Yeah. So it's a more case by case basis thing. And so we took these strategies, and we are prototyping. So we spent day 1 coming up with the strategy, and then day 2 we began prototyping for with these priorities in mind. So one of the big things that we used before building our prototypes was a prototype evaluation matrix. And so a lot of the issues that our team had last year were we were very much a voting based like design team. And so we would vote by being like, oh, who agrees with this prototype and who agrees with this prototype? And then we'd vote. And one thing we noticed was there was a lot of bias that came in with that, because we were like, oh, we trust this senior that knows a lot, and we would go with their opinions. But we decided to try out an evaluation matrix this year to add a objectiveness to our design process and choosing which prototypes. So currently the matrix isn't what prototypes we're going with. These were the list of prototypes that we came up with at the end of kickoff day 2. And so we began to rank them on mech simplicity, programming simplicity, system simplicity, also known as electrical for our team, and then robustness, repairability, and agility. And so this is before we built the prototypes, to see which prototypes we would actually build, because our mech team can only build so many with the number of team members that we have. So yeah, and then from there we have spent the past 5-ish days doing half-life prototypes. So just bringing out that proof of concept, trying not to go too far into the design process with those prototypes, and then we reevaluated, and then we got to the half prototype matrix.
It's right here.
Yeah, and it's a little incomplete, and we shifted.
Before we jump on to the next tab there, I just want to say that your prototype names are like chef's kiss, like
Thank you.
quite excellent.
Yeah, so we'll go through the prototypes, and there's a story behind all of them. They're actually very intuitive once you see the prototypes. Tiger, can you bring the prototypes?
Yeah. All right. So of the prototypes we have right now, we have Unicorn. Let's just go down the list. We have Unicorn and Barbie.
So we called this one the Barbicorn simply for prototyping purposes, because they're very similar. But this is the Unicorn because it's just a piece, like a shaft sticking out from a like other rolling shaft, and so unicorn like a horn basically.
Yep.
And so the concept is it would go in, the cone would go inside of it, and then it would just tilt up and then intake the cone. So it's one of our more simpler designs if you look at the matrix, which is why it scored the highest at 12. We had the play button, which was one that didn't make it through because it did score pretty low. It got 8.1 on our evaluation matrix, so we won't be going over that one. We have the pooper scooper, which we came up with because it was a passive mechanism, and so we were like, it just scoops. So what word has scooping? Pooper scooper. And so, Tiger, you want to talk about how it works?
Yeah. So essentially the goal of this one is to kind of get the cones into an orientation like this, basically by just driving along and then hitting it and then tipping it upwards, so that now you have a cone in a known orientation that you can, do as you please. And then we've got slides that would give a little extra grip for cones or cubes.
And then our other one is the interpretive dance. Now this one is called the interpretive dance because every time we had to explain it to each other, because we were trying to explain to each other our ideas for it, it made like no sense, and we would have to basically do a lot of hand motions to explain how it worked. And it is our by far most complicated intake mechanism. So I think there's a video that Tyler has. There's like 3 of them.
Is that the one that has everything going in the middle?
Yes, everything goes in the middle.
Yeah, this one's pretty nuts here, Greg. I haven't seen this, but
I haven't seen it. This is gonna be live.
Yeah, so that's pretty cool, guys. So they go through. Yeah, definitely from that type of intake, having all 4 of those in there. Did you try from different angles or anything like that, or is everything kind of straight on with it?
So the way it worked is we went in from the side, and we went with the triangle part, the narrower part first, and then we went in from the base end. And I think we went in diagonal, not too sure. But the whole concept is there would be wheels that are spinning in opposite directions so that it would always land base first, base upwards, because the base is the widest part. And so hopefully it would be able to take in from any direction, which is why we gave it a like agility, the highest score on agility, because it would be able to pick up in any orientation, whereas our other intake mechanisms are more limited.
and we've done a fair bit of iteration since that video. We've kind of slanted out the entire mechanism instead of making it flat.
Yeah, it's
So-
all wobbly now.
Yep.
And so we still are trying to decide what kind of intake mechanism, because even though that one is really cool and it picks up in many different orientations, we're trying to balance the trade-offs. So
And is that one that you are gonna, like, you would put that on a hinge on the outside of your robot and it would like fall down, or is that something this would be like on the inside of your robot to orient them as they come in?
our idea is like you drive over the game piece and it intakes as it comes in. And so it would be on the inside of the robot, hopefully, because it would not be a very nice thing to repair, which is why it has a 1 on repairability on our Matrix.
So that's pretty cool. So you're talking about like, so you would have like solid bumpers all the way around and you would just drive over them and that'd be like in the middle of your robot and just
I
kind of
think
pop
it's
them
more
up?
like
or-
a
Yeah.
U-shaped robot in a sense,
Uh-huh.
like an opening towards the front. We're still trying to figure out base dimensions, and we're hopefully going to finalize that by the end of this weekend.
Okay. So what's your process? So we've seen a couple of your prototypes, and what's going to be your process for how do you decide which one you're going to actually move forward with? So you've got your rankings, or like your pre-prototype rankings. Are you going to revisit this same list for now that you've built them, or what does that process look like?
Yeah, so we have a half-finished Half-Life prototype, which is what we did. So we had 5 days for the first half of prototyping, and so that's where we took the prototypes that we went in with, and we finished them all. So we reevaluated them and re-ranked them, and we kind of like rearranged. You can see there's definitely less picking prototypes, and it's between the unicorn and the interpretive dance. And then we have like new linkage systems, and so this second half of prototyping goes more into integration, and we've started to think about like how our different prototypes are working together versus prototyping them independently. And so we have a performance category that is like newly added, so that instead of like in the beginning it's all arbitrary, everything's like relative to each other, we're trying to guess. And so the performance category is intended to see how they actually work and if they actually work, and so that'll help us narrow down which prototypes are actually going on the robot.
Got it.
Looking at other stuff for your season so far, what are you looking at doing for a drive base? Is there anything else from programming or vision side you want to talk about that your team is looking to approach this season?
Yeah, so we're gonna go with Swerve Drive because we figured the game would work really well for Swerve Drive and being agile, and especially being on the charge station. Like if you had to shift for your alliance team members, it would definitely be more helpful to do Swerve Drive than a tank drive. As for programming, I think we're working on April tags. Not too sure. Yeah, April tags.
We've been working on photon vision and April tags, all that, pose estimation, all that fun stuff.
Yeah.
Got it.
And then
Are we 4 for 4 tonight, Tyler, on Swerve drives, on Open Alliance team members?
I have to think back. I thought we had one that was not, but I'd have to go back. My memory doesn't serve me too great on things like that, but definitely majority Swerve drives for sure. So interesting to see him there. NRG, by the way, just a couple things. I really appreciate the matrix that you shared on there. That's something, when we look at teams and how they go about decision processes every year for that, I love seeing things like this. Even back when I was a mentor, we were utilizing these, and this is such a great way to help us get a great start and start to prototype and determine what's working, what's not, that sort of thing. So kudos to you on that, and thank you so much for sharing that with us. Before we wrap up here tonight, anything else that you want to talk about? And maybe we're, we won't see you for 3 more weeks during the OA show. So where do you kind of want to be in the next couple of weeks? What are some next immediate steps for your team to accomplish?
Yeah, so for our team, our next steps are to get the drive base done as soon as possible, get it to programming and drive team to start testing some auto paths, getting some drivers, some new experience, that kind of stuff. And then hopefully in 3 weeks, we'll have we'll definitely have our prototypes like end of their life, and full robot CAD, and then start building. Maybe the robot will be done in 3 weeks. I'm kind of being optimistic, but if our mech team pulls off well, then we'll have a hopefully functioning robot in 3 weeks.
And we've got finals right in between that. So
Oh,
this'll
lucky
be
you all.
Yeah.
Well, Greg, I don't know about you, but I have confidence in them, so I think they'll get it done, and I can't wait to see.
It sounds like it. What week do you guys compete in your first event?
So for us, we've got, I think, week 3, Bonnie Lake, and week 4, Sammamish High School.
Okay, so you've got a couple bonus weeks in there, so it's not a pure 6-week build season for you. But no, I look forward to seeing what you're going to come up with in just a few weeks. And don't forget, finals are more important than robots, even if they're not as much fun.
I know about that.
I just want to say, I did not notice that you're going to Bonnie Lake. I'm very excited for that because I think I will be out at Bonnie Lake this year. So I look forward to seeing your team compete out there. It'll be so cool.
That'd be fun.
Awesome. Well, NRG, thank you so much. Wish you best of luck, and can't wait to see what you come up in 3 weeks. Thanks a lot.
Thank you for having us.
Yeah, of course.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. SOLIDWORKS is free for FIRST teams. Over 80% of U.S. engineering schools and 370,000 plus companies use SOLIDWORKS to design great products. SOLIDWORKS can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.